Alright, this is the tutorial for rock, paper, scissors with Python. Let's just start a new Python project. We can just call it rock, paper, scissors or RPS or something. I'm going to close the sidebar. And let's start with some pseudocode. Let's see if I've got the AI autocomplete off. Good. Okay. So some pseudocode. The requirements say we need to have an option for the user to do a single rock, paper, scissors battle with the computer, or a best of 3 match. So let's just start some pseudocode there. Let's say option 1, single battle. Option 2, best of 3. In fact, it's pretty easy to set up a menu for that. Just do some print statements. We can say rock, paper, scissors. Choose an option. And then we can say something like 1, single battle, 2, best of 3. Okay. So I said we were going to do some pseudocode. I guess we should do that. The way I'm going to do this, I want to build a function that we can use with both of these options. So if we've got a function that can perform the single battle process, it'll be really easy to just make it happen 3 times for the best of 3 option. So maybe let's start up here with a what do we want to do inside of this function? We need it to return whether or not the user beat the computer. So maybe we could return a 1 if the user wins, a -1 if the user loses. Sounds like a good way to do it. So let's say return 1 if user wins, -1 otherwise. What else do we need this function to do? We just needed to ask the user to make a choice and then randomly have the computer make a choice and then do a bunch of if statements. So ask user to choose R, P, or S. Have computer randomly choose R, P, or S. And then we can say if computer is R and user is S, that means the computer wins, right? So return -1. And then there's several other cases, right? And this is easy enough. I guess we don't really need some pseudocode, so let's just start coding it. Let's say define a function called RPS battle, maybe. Oops, we need to have that. So let's start by giving the user a choice. Let's just say make a choice. Rock, paper, or scissors. And then we can store their answer in a variable called user choice. Alright, and then we gotta have the computer randomly choose one of those 3. So let's import the random library. And then we can say computer choice equals random.choice. And then we can pass in a list here. Maybe let's just create the list outside of that. And then we pass it in those parentheses. So let's create the list of options. We can say options equal, and then rock. Should we keep it all lowercase just in case, or make it easier for them? Yeah, let's do that. So it'll be all lowercase values. Rock, paper, oops, wow, scissors. There we go. Okay, so that's going to go in as the options for the computer to randomly choose from. And at this point, we just have to check who the winner is. I'm going to remove that. What are the different ways that the computer can win, and what are the different ways the user can win or nobody wins? I think the easiest thing to handle first is the case where neither of them win. all we have to do is check if user choice equals computer choice, and that would mean it's a tie, right? And what do we want to have happen if it's a tie? We probably just want to redo the battle, right? So actually, we can use recursion. Yeah, let's do that. So we can say if, sorry, recursion is a concept that we usually don't teach until, well, several classes later. You'll probably learn more about recursion in college and stuff, but it's a powerful concept, allows you to call a function inside of itself. Anyway, we'll see if it works here. So if user choice equals computer choice, that means it's a tie, so we can say try again. And then we just need it to run the RPS battle function again. See what we're doing there? We're recursing. And it could potentially go on forever, right? It's kind of like a while loop, but it's even more powerful and potentially more dangerous. So yeah, we call this function inside of itself in the case where it needs to try again. But we don't want to just call it, we want it to return whatever it gets back from that. So we've handled the tie. Let's just move on from there. So we can say else, and we just need to decide who the winner is. So we can say if computer choice equals rock and user choice equals paper, that means the user won. So we can say return a positive 1. There's also a case elif computer choice equals paper and user choice equals scissors. That means the user won, so we return a 1 in that case as well. I don't like these. Let's just do an if there. The other case is if the computer choice is scissors and the user choice is rock. That means the user won as well. So all 3 of these cases mean the user wins. And there's only one other possibility, or sorry, there's 3 other possibilities. But if none of these happen, it means that the computer won, right? If none of these statements are true, it means one of the other 3 conditions is true, where the computer wins the battle. So I guess we do want to have it be elif statements in order for us to just handle this all with an else case and make the computer be the winner. So in any other case, we return a -1, and it means the computer won. Okay, so I think we've got the function written. Now we can use it everywhere we need it. So let's see, RPS battle. We can say option equals input. And then we can say if option equals 1, that means they did a single battle. So we just do RPS battle, right? And we could even do an if statement around it. Or we could say if that results in a 1, that means we won, right? The user wins. So we can say, good job, you win. We should probably also say what the computer chooses, I just realized. So computer choice equals random choice. Right after we do that, we want to print out what the computer's choice is. Computer chose, and then we can say computer choice. There we go. And now we can handle the other case where the computer wins. We can say otherwise print you lost. Okay. We've done a lot of coding and not a lot of testing yet. So let's test everything we've done so far. Make sure that the first option works. So let's just choose option 1. It says make a choice, rock, paper, or scissors. I'm going to say rock. It says computer chose scissors. Good job, you win. Perfect. Let's try it again, see if it works with other cases. I'm going to choose rock again this time. Oh, it looks like the computer also chose rock, so we have to try again. I'm going to choose rock again. And the computer chose paper, so this time I lost. Perfect. Let's try one more time. I'm going to clear out that. Let's say I choose paper this time. And it also chose paper, so I'm going to choose paper again. And then the computer chose rock, so I win. Perfect. So we can see that option 1 is complete, and the function that it uses appears to work correctly. Okay, so let's move on to option 2, which is to do a best of 3 and report who the winner is. So let's set up a elif option equals 2. Now for the best of 3 part, we can just have it call the RPS battle function 3 times, right? If we just did this. But we're going to have to keep track of who the winner is for each one. So maybe we can say something like game 1 equals, game 2 equals, game 2 equals, and game 3 equals. Now we know that it's returning a 1 or a -1 each time, right? So one of the cool tricks we can use is if we just add up these 3 variable values, if they end up being a positive number, it means that the user won the best of 3. If it turns out to be a negative number, it means the computer won best of 3. So let's just add them up. Let's say total equals game 1 plus game 2 plus game 3. And we could say if total is greater than 0, then the user won the best of 3. We can say, good job, you won the best of 3. And then we can say else print, sorry, you lost the best of 3. Okay, so it should be complete. Let's test it. I'm going to clear that out. Let's make a choice. Paper, computer chose rock. If we chose paper and they chose rock, it really means we won the first round. Let's try rock this time. And they chose paper that time, so now they won the second round, so it's a tie at this point. So whoever wins this one is the total winner. So I chose paper, they also chose paper, so we got to try again. I'm going to choose paper again. They chose rock. I win the best of 3. Okay, so one thing I'd like it to show is who wins each round as well. So maybe just after each one of these we could say computer wins or user wins. Yeah, we can say if game 1 is greater than 0, it means you won the first match, right? So we can say print you won the first match, or the first battle. I guess we're calling them battles, huh? Otherwise, print computer wins the first battle. Right? We can do the same thing with this. If game 2 is greater than 0, then print you won the second battle, right? We'll say else print computer wins the second battle. And then the third one. If game 3 is greater than 0, print you won the third battle. And else print computer wins the third battle. Alright, so let's try it one more time. Should be all done. Let's say best of 3. I'm going to choose rock. Try again. Okay, rock. Perfect. We won the first battle. I'm going to choose rock again. Perfect. We won the second battle. So if we wanted to, we could program it to where if we won 2 in a row, it doesn't even do the third battle. But we're keeping it easier. So let's do rock a third time in a row, and this time we lost it, but that's okay because we still won best of 3. We won the first 2. Now it'd be a good idea to make it so it checks and makes sure that whatever we enter is one of the available options. So you could do some error checking. After they make their choice right here, you can make sure that it's either one of these 3 things or force them to try again, right? I'm not going to do that, but you're welcome to add that if you want. Okay, and we are done.